In this lesson, we're looking at starting what we call matrix operations. What we're going to look at today are the basic matrix operations of addition and subtraction, and we'll also look at basic multiplication. We need some definitions first. First definition we've got is the word matrix. What is a matrix? A matrix is a rectangular arrangement of numbers in rows and columns. When you look at a matrix, we are going to use these square brackets around the matrix. And when we label matrices, we always label them with capital letters. This would be an A matrix, and then over here you have a sample of a B matrix. Every matrix has what's called a dimension. Your definition for dimension. Each matrix has a size listed as row by column. We see this letter X right here. We're going to use the word by for that. Row by column. So this A matrix has 2 rows. It also has 2 columns. So the dimension of the A matrix is 2 by 2. Here's a sample B matrix. As you can see, we've got 3 rows and we've got 2 columns. So this matrix is of dimension 3 by 2. When you read matrix numbers, you go from left to right like you read a page and top to bottom. When I read this A matrix, I would say 3, 4, 2, 9. My B matrix would be 5, 3, 9, negative 1, 3, 8. Your next definition is the word element. The elements are the actual numbers in a matrix. 2, 4, those are numbers in a matrix. Those are elements. Matrices can be added or subtracted if they have the same size, if they are the same dimension. If an A matrix is of size 2 by 3 and a B matrix is of size 2 by 3 and they match, then your answer matrix, letter C, is of the same size 2 by 3. Let's look at these two examples. Your first matrix is the numbers 2, 4, 0, 1. This is 2 by 2. Your second matrix is also 2 by 2. That means these two matrices can be added together. Now when you add matrices, you add like spots. The upper left corner gets added to the same upper left corner. 2 plus negative 3 is negative 1. Your upper right corner goes with the upper right corner. 4 plus 2 is 6. 0 plus 4 is 4. And 1 plus 0 is 1. So we have a matrix that we would call letter C that is the same size as the original A and B matrices. All right, let's go to the second sample. Each of these matrices is of dimension 3 rows and 2 columns, which means these two can be added together. Like spots, in the upper left corner, 4 plus 2 would be 6. 6 plus 3 is 9. In my second row, negative 2 plus negative 4 is negative 6. 2 plus 2 is 4. 1 plus negative 3 is negative 2. And 5 plus 1 is 6. And here we have our answer matrix, which we would call a C matrix, that is of the same size, 3 by 2. The other basic operation that we do with matrices is called scalar multiplication. Scalar means we're going to have a constant in the front of a matrix, and we're going to treat that scalar like a distribution. That number will get multiplied to every single value inside the matrix. It does not change the size of the matrix. If it starts as 2 by 2, it'll stay 2 by 2. Here's a sample. We're going to take 4 and we will distribute it through everything inside this matrix. 4 times 3, 12. 4 times negative 2 is negative 8. 4 times 0, 4 times 3, 4 times 1 and 4 times 6. And you have the same size matrix, 3 by 2, that's been multiplied with a scalar. Here we have a sample equation. This will be the last thing for this lesson, where we have a distribution of the scalar 2 through everything, but you notice we've got parentheses here. So if you remember your order of operations, we're supposed to do parentheses first. So I need to add these two 2 by 2 matrices together. Now remember, when you do matrix addition, you add like corners. 2x plus negative 1 has to get added together first. Well, since those aren't like terms, all I can do is put them next to each other, and that would be my first position, 2x minus 1. The next position is negative 3 plus 4, that's 1. 5 plus 3 is 8, and negative y plus 5 is again just that, negative y plus 5. So this is the matrix addition, and I still have my distribution with the scalar 2 in the front of that. So now I'll take care of my distribution. 2 times everything that I see in this matrix. On the first one, I actually have a distribution. 2 times 2x minus 1 is 4x minus 2. 2 times 1 is 2. 2 times 8 will be 16. And here I have a second distribution. 2 times negative y and 2 times 5. This matrix on the left-hand side is now supposed to be set equal to the answer matrix, which we were told was 10, 2, 16, 14. Now, if we look in like positions, my upper left corner of 4x minus 2 needs to be set equal to the number 10. I can write that off on the side as a simple equation that I will know how to solve. 4x minus 2 equals 10, 4x equals 12, and x equals 3. So my unknown piece x is 3. Now if we continue looking through the matrix, 2 equals 2, yes, that's a true statement. 16 equals 16, that's a true statement. And in my last position, I have negative 2y plus 10 is supposed to equal 14. So let's take that one out separate as well. Negative 2y plus 10 equals 14. And let's solve that. Subtracting 10 on both sides, negative 2y equals 4, and y equals negative 2. So we were supposed to solve for an unknown piece, and we just did. X equals 3, and y equals negative 2. There you have simple, basic operations for matrices with addition and scalar multiplication.